video, we'll take a look at converting between radians and degrees. And what we want to do is tackle the easiest ones first, where we can start to go into automatic mode and start to recognize some of the patterns. So what we're going to start off with is the idea that 360 degrees is the same as 2 pi radians. I'm going to write the word radians here, or abbreviate it, but remember that if we just write 2 pi and there's no degree symbol, then we mean radians by default. You can leave that unit off and it's okay, but here we'll try to write it just to emphasize our radian measure. So if we think about 180 degrees, that is half a circle, and then that means our radian measurement is pi radians. Similarly, if we keep on cutting in half, 90 degrees is going to be a pi over 2 radians. And if we cut in half again, then we can think about a pi over 4. Now, we can also go in some other different directions with this. We can think about our 30 and 60 degree angles by thinking about going from the 180 degrees being converted to pi radians, and think about how to transform to 60 degrees from 180. So if we think about 180 to 60, we're dividing into 3. So if we take our pi radians that corresponds to 180 degrees, we would divide that by 3. And 60 degrees is pi over 3 radians. Similarly, if we were looking at 30 degrees, we're dividing that 180 by 6, so you're at pi over 6 radians. Then we can also take these and scale up. For example, if we had something like 5 pi over 6, maybe going the opposite direction now, then that's 5 times pi over 6, or 5 times 30 degrees, so 150. So what you want to do is think about knowing some of your core angles. I kind of recommend this set. And then if you see ones that are multiples of these, you can scale up as needed. Let's do one more example. Let's say you had something like negative 2 pi over 3. Here, we've worked a lot with positive measurements in this part so far, but remember that a negative radian is just moving in the opposite direction. So you're just moving clockwise instead of counterclockwise. So if we think about negative 2 pi over 3 radians, that's going to be a negative degree measurement as well. Pi over 3 is our 60 degrees, so 2 times pi over 3 is going to be 120. All right, so once we have a pretty good grasp of the easy ones, if we're trying to convert in this particular scenario, we don't necessarily need to work any harder than this. But sometimes when we're looking at conversions, it's helpful to have a conversion factor. And in fact, the conversion factor that we're going to use is kind of based off this idea of 180 degrees equaling pi radians. This allows us to write a conversion factor one of 2 ways. It allows us to write 180 degrees over pi, I'm going to put the radians in, or we can utilize the idea of pi radians over 180 degrees. So we're going to use one of these two to convert when we're converting from one to the other. Which one we use depends on what we start with. So let's take a look at a quick example. I'm going to start with a degree. So let's say we want to go from 220 degrees and we want to know how many radians that is. So if we think about 220 degrees, we've got to get rid of the degrees and go to radians. So what we want to do is think about using the conversion factor that's going to cancel the degrees out. One tip that I like to do is just to put this over 1. And then what we're going to do is put our degrees on the bottom. Kind of like if you're canceling x's on the top and bottom of a fraction, we are going to do a unit analysis and cancel these units. If you've done conversion factors in chemistry, it's kind of a similar idea, but this will allow our degrees to cancel, and it's going to leave us with the radian measurements that we need. So in this particular case, if we multiply the tops, we get 220 pi, and then on the bottom we get 180. Now, this is a radian measurement, but it's not in simplified form. And I'm going to wait and add the word radian at the end, because what I want to do is reduce. So this is really 22 pi over 18. Or if I think about taking it a step further, I could say this is 11 pi over 9. Now, when we're thinking about this particular scenario, most of the time we're going to be dealing with one like this by hand. And in fact, sometimes examples will say, leave your answer in terms of pi, meaning they want 11 pi over 9 rather than a decimal approximation. We'll kind of compare in just a moment with a decimal approximation. But it might also say something like, don't use a calculator. What they're wanting you to do is avoid converting to a decimal. Now, in this particular scenario, if you want to use Desmos to check your fraction work, let's say some of these fractions you kind of get stuck reducing or you're not sure if they can reduce any further, I'm going to show you just a quick shortcut or a quick Desmos trick that you can use to check these, but try working them out by hand and then using Desmos to kind of just check your fraction work. All right, so if I were going to let Desmos check this, I would go ahead and type in my 220, and I'm just going to put it in exactly like I wrote it here. My 220 over 1, we can put that in parentheses if we like or leave it out. And then I'm going to do pi over 180. Now, the reason I'm showing you this first is because this is going to give you the decimal. So if we're thinking about 11 pi over 9, that is radians. And then as a decimal approximation, if they'd ask you for a decimal approximation, that would be about 3.84. Okay, again, most of the time you're going to leave your answers with a pi, but what you want to remember is pi is really about 3.14. So 180 degrees is about 3.14 radians. So 220 should be a little bit more than 3 radians, but not quite 4 in this case. So only give that decimal answer if they specifically ask you for a decimal. But the shortcut on checking your work is if you want to be able to just check your fractions, take the pi out and put a 1 there. And then what you can do is add the pi back in after you ask Desmos to simplify this fraction. So when you take the pi out, it allows you to work out that multiplication. And then if you press the fraction key right here, it turns it back to 11 over 9. And then you just add the pi back. So 11 pi over 9 or 11 ninths times pi. You can kind of think about it either way. So let's go ahead and think about another example. So let's suppose we wanted to go ahead and we'll change colors here. Let's say we wanted to go back to the idea of 1 radian. In the example where we had 1 radian, and we want to know how many degrees it is. Well, we can kind of visualize 1 radius wrap, and it looked like somewhere between maybe 50 and 60 degrees, but using our conversion factor allows us to calculate that more carefully. So when we have 1 radian, you can start by putting it over 1. And then the conversion factor that we need to use this time needs to have the radians on bottom. So I'm going to look at radians on bottom, which means that I'm going to use the first conversion factor where I have pi radians on the bottom and 180 degrees on the top. So that when I multiply through, I get rid of those radians and I get 180 degrees over pi. Now, in this particular case, we typically don't leave our answers that have degrees with a pi in them. So I would just go ahead and type into Desmos 180 over pi, and that is giving me approximately 57 point, we'll call it 30 to 2 decimal places, degrees. So in this particular case, we just want to make sure that we're setting up our conversion factor correctly. You have to think about if you're given degrees, then the 180 degrees goes on the bottom and your pi radians go on top. And if you're given radians, then your pi radians go on bottom and your degrees go on top. Let's take a look at one more example in this particular case, because instead of 1 radian, sometimes they may give us a radian measurement that has a pi in it, and we want to make sure we can handle that. So for example, let's suppose that they give us 5 pi over 18. So this is an angle measurement. It's in radians because we don't see anything. We don't have to write the word radian, remember? And they ask us, how many degrees is this? Or they say, convert to degrees. So in this particular case, we have to think about just kind of mentally adding the word radians back. And then what I like to do, just to get me started, is to put this over 1. Sometimes I even put it in a different color, because that allows me to really think through my conversion factor. and it allows me to put the radians on the bottom and the degrees on the top. I'm always thinking about canceling those units, and that helps me figure out which one is which. So we know that in 180 degrees, or pi radians is the same as 180 degrees. So when we look at other things that can cancel, notice in this case, we can cancel these pi's. If it makes you uncomfortable to kind of look at that fraction over a fraction, you can just go ahead and rewrite this. For example, you could write 5 pi over 18 and then just leave the word radians, or put the radians like this, and then kind of cancel like this. Either way you do it, you can either write 5 over 18 and then you kind of have an over 1, but that's still, sorry guys, I wrote an extra pi in there. Let's fix that. Sorry, the pi we canceled. Sorry about that. So this should really be 5 over 18. And then you could either write a 1 or just leave it as 5 over 18. And then times a 180. And remember, if you cancel that pi, that's like a 180 over 1. Or, again, kind of cleaned up, this is 5 over 18 times 180 over 1, or just times 180. So if we're thinking about simplifying this by hand and not using a calculator, it's not too bad, right? We could do it. We're going to check on Desmos in a moment. So we could reduce this to 1 and 10, and then 5 times 10 gives me 50. So 50 over 1, or 50 degrees. Now, if I am double checking this, keep in mind that because these pi's cancel, or because I'm seeing that, I can just drop it in. So for example, I could do 5 pi over 18. And then if it were me putting it into Desmos, I probably would not put the over 1. I would just kind of put this part, and then I would multiply by 180 over pi. Now notice when I put it in like that, Desmos is able to cancel the pi's because it's the same term, and I get the 50 degrees. You could also think about like using Desmos at any step just to kind of check any sort of arithmetic work that you're not sure about. All right, so that is it for this video. We want to make sure we practice going in both directions. Just pay attention to the directions, whether they want you to leave your answer with a pi, often that's without a calculator, or they want you to convert to a decimal.